Good day, everyone. I will be discussing the current and potential difference in circuit, and also the series and parallel circuits. To begin with, let us recall the Ohm's law, wherein the Ohm's law is the relationship between the current through a resistor and the potential difference across it. So in this diagram, you can see a resistor that a current flows within a wire and also through the resistor, which having a change in the voltage. So to, pro, to provide a certain formula, we can indicate that the current is equals to the change in voltage over the resistance. So potential difference is the difference in the amount of energy that charge carriers have between 2 points in a circuit. To measure this potential difference or the amount of energy and also the current flow, we can use the measurements in circuits, which is the ammeter and also the voltmeter, wherein ammeter measures the flows of the current that pass through it, while the voltmeter measures the potential difference between 2 points in a circuit. Okay. What is the difference between the current and potential difference? So when we speak of current, this is a flow of charge, and it also measured through a component. So as you can see here, on the left side of the diagram, the voltmeter is parallelly attached to the end of the both ends of the resistance. While the potential difference is energy used between 2 points in a circuit. So therefore, it is measured between 2 points either side of a component. So on the right side, you can see that the ammeter was attached in a series circuit. So let us discuss the circuit elements and diagrams. In a circuit elements or diagrams, we have the resistor and also the capacitor. To further elaborate what are the symbols we use in a certain circuit, uh, for the battery, we have here the long line, which is perpendicular to a wire, is a positive charge, while the short line is the negative side. So for the line, we have a straight line. The resistor is a zigzag line. A bulb is also a resistance or resistor, which has a curl line inside a circle. While the junction is a perpendicular line, and we have also the capacitor and switch. Okay. So in a certain diagram, this is the proper arrangement of a certain circuit of a current flow or a voltage diagram for each series circuit or certain parallel circuit. So on the left side we have the battery, in the middle one we have the resistor, then for the right side we have the capacitor. Okay, so let us discuss the series and parallel circuits. So when we speak of series, all components are connected end to end, forming a single path for electrons to flow. So uh, to further understand, in a series circuit, we can say that the the flow of energy or electrons is from one end to the other. So it flows from one resistor to another resistor, then go back to the negative charge of the electron. Okay, so on the other side, we have to say that the electron flows from negative to positive. Okay? While the current is from higher point to lower point. Okay? So in a parallel naman, all components are connected across each other, forming exactly two sets of electrically common points. So as you can see, that the current flow or electron flow can flow here or either here. Okay? So yan po yung ating basis. So to sum this up, if the resistor increases, the current flow decreases. And if if the resistor decreases, the amount of current flow increases. Yeah. So usually in a series, uh, the first bulb will be brighter while the second bulb will be not as brighter as this first one. No? While in the parallel, both light is brighter. So we will explain later why parallel loads in the parallel loads both bulbs will be brighter or will having the same current flow. So let us discuss the Kirchhoff's law. So in a Kirchhoff's junction, law states that the total current into a junction must be equal to the total current leaving the junction. So this is a result of charge and current conservation, wherein uh, when the current flows goes in, it will be equivalent to the current flow that goes out, and the total current would become zero dito, no, at it reaches the endpoint in A. So let's say kung 30 volts dito, so yung last would be 0 volts. So to explain further, no, Kirchhoff's law uh, would flow the electron from higher potential position to the lower position. So that would be equivalent to constant or zero. Okay. To explain further, no, let us have example problem. Let's say we have 30 volts and we have two resistor, no? Then we have another resistor which is the 4 ohms. Now, to to check the total resistor, okay, the total resistance. So gave a formula of R1. Let's say this is R1, R2. Then we add the another resistor that will be equal to 6 plus 4. That will be equivalent to 10 ohms. So that will be our total resistor. Now, let us identify what is the current flow, no? Current flow that flows within 6 ohms resistor and a 4 ohms resistor. So to find that, what would be the current flow, let us use the Ohm's law. So kanina na we recall the Ohm's law. So as we can see that the voltage here is 30 volts, then equivalent to the unknown current times 6 resistor and 6 resistor para malaman natin yung voltage drop, no? No? Since 6 yung una natin, then we add up by 4, no? So that would be equivalent to 10 ohms. So our total resistor is 10 ohms. Then we will cross multiply, or we will divide both side by 10. And if we will divide this both side by 10, this will become 3 ampere. Ayan. So yung current flow natin dito is equivalent to 3 amperes. So now, let us identify the voltage across, no? 6 dito sa 6 ohms and also the 4 ohms. So the voltage will become the, let's say this is 3 amps, no? So we have 3 amps times the resistor 6 ohms, that will become equals to 18 volts. How about in 4 ohms, no? So the voltage across 4 ohms is 3, the current is 3 amperes. Then we have 4 ohms, that would become to 12 volts. Ayan. So as you can see, when we add up this one, 18 plus 12, that would be equivalent to 30. Now, so in a certain closed loop, if we add up this one, that will be equivalent to 30. So the last drop would be for the voltage to come is not 30, not 0. So we add this one, this is also 30. So 30 volts, yung initial natin minus 30 volts, that will be equivalent to 0 volts. So alam naman natin na yung baterya ay nagsusupply, no, ng current dito sa resistance natin. So dito natin na naintindihan na yung voltage drop consumes energy in a circuit, and that will be equivalent to 0. And that would be our Kirchhoff's law, no, in identifying this one. Okay. Okay, now, next. So next problem, let's say we have ayan, let's say meron tayong tatlong voltage, tatlong resistor. Let's say we have here 60 volts. Then let's say we have 5 ohms, 3 ohms, and 2 ohms. Okay. So let us find the total resistor for this. We have the total resistor is R1 plus R2 plus R3. So we will add up this one, no? So 5 plus 3 plus 2, that will become to 10 ohms as our total resistor. Now, let us identify what would be the total current, no? Or the current flow rather for this. So let us use the Ohm's law. V is equals to I times R. So our voltage is 60 volts is equals to the unknown current times the resistor is 10 ohms, our total resistor. So let us divide this one, and that will be equivalent to 60 divided by 10, that will become 6 ampere. 6 ampere. Now, let us identify naman yung current, voltage across each resistor. So, to find out the resistor, now same, we will use the Ohm's law. So, for 30, we have 30 volts is equals to, sorry, 60 volts. 60 volts is equals to, our current is 6 ampere times 5 ohms. No? Ay, hindi pala muna na, wala pala tayo. Voltage across nga pala. Voltage across is equals to 6 ampere times 5, so that will become 30. 30 volts. Next, ito naman, no? 6 ampere times 3 ohms. So that will become 18. Tama ba? 18. 18. 18 volts. Next, ito naman, no? Six. So it's 18. 6. So, yung next natin is 6 times is 2 is 12, no? Is 12. Yan. So, if we will add up this one, this is 30. 30, that will be 60. So, ayun pa rin, no? Yung ating total voltage is 0 volts in accordance to Kirchhoff's law, no? Yan. Then, so let us check if the power, no? Gaano ba kalaki itong power na to, no? Yung lahat ng ito. So, to do that, okay? So, in power, V times I. So, we have 60 volts, no? And we have 6 amps of voltage. That will become 360 watts of power. Yan. Pagin natin dito. Okay. So let us identify the power for each, no? So let us use the Pi squared. P is equals to I squared times R. So that will become 6 amps squared. Then we have resistance of 5 ohms. So 6 times 6 is 36 times 5 is equals to 180 watts. Yung second, so let us use PVI. Our voltage natin ay 18 times the resistance is 6. Okay. So let us multiply 18 times 6 is 108 watts. For the third, let's say we use the formula B squared over R. We will have a voltage for this one is 12. Diba? 12 volts squared over R. Yung R natin is 2. So 12 times 12 is 144. Divide by 2. So divide natin sa 2. That will become 72 watts. No? So yung wattage nito, yung natin blue, yung una is 180 watts. Second, we have 108 watts. And to the third one is 72 watts. Now, i-add natin, di ba? So, 180 plus 108 plus 72, that would be equivalent to 360 watts. So, same with Kirchhoff's law. So, 360 minus 360, pag sinubtract natin, will be equal to 0 wattage. Ayan. So, yun lang siya, no? Okay. Tayo. So, let us have our example for the series. So, sa series naman, since multiple yung kanyang current flow, no? Let's say 24 volts is the voltage. We have 6 ohms and 8 ohms resistor. Yan. Paano natin ngayon i-solve yung resistor, no? Ng kabuuan, no? R1, R2. But in parallel, we will divide by 1. But before we get the total resistor, no? So let us identify first the current na dumadaloy dito sa unang resistor. So we will use the Ohm's law. P is equals to IR. Our voltage is 24 volts. And our current is unknown. And our resistor here is 6 ohms. So let us divide 24 divided by 6. That would be equivalent to 4 ampere. So yung nagpo-flow na current dito is 4 amps. At 24 volts. Para sa point na to. Okay? And yung papunta dito sa baba, that would be 0 volts in accordance to Kirchhoff's law. Yan. Now, so ulitin natin, no? Yung position na ito, pagka sa ilog, no? Yung stream, nagpo-flow siya from higher potential to a low potential. So, same with voltage. Ganun din. Sa iba, ito ay tinatawag na electromotive force, no? Yung from higher position to lower position. So, i-check naman natin yung current na dumadaloy sa 8 ohms na resistor. So, we will use the same formula. V is equals to I times R. So, 24 times the unknown current times 8. That will become 24 divided by 8 is equals to 3 amps. No? So we will have here 3 ampere. Ayan. So kung i-add natin to, no, we have 7 amps of current. Ayan. So kapag in-add natin, no, so Kirchhoffs pa rin. So 4 plus 3, that will be 7, or 7 minus 7, that will become 2. 0 pa rin approaches to 0. Okay? Okay. Now, we will need to find the uh, equivalent resistance, no, for this one. So, ito na yun, no, yung total equivalence resistance. So, we have to find. So, dito, makikita natin, i-divide natin yung dalawang resistor by 1 sa bawat isa. Okay, so, to check muna natin, no, para makuha natin yung requirement nito, we will use also the Ohm's law. So, let's say the 24 volts is equals to, meron na tayong total of current, so 7 ampere. Now, we will find the total resistance, so as equivalent, no? So 24 divided by 7, our total equivalence resistance is 3.43 ohms, no? So kung mapapansin nyo dito, yung kanyang resistance is mas mababa kaysa sa kanyang current. Yan. Kaya, yung kung ito ay ilaw, pare silang bright. Yun yung sinasabi natin kanina. Or, pwede nating gamitin din yung requirement as the total resistance will be equal to 1 over R, then 1 over R1 plus 1 over R2, so that will become to 1. So, yun dito yung resistance natin is 6. This will be, di-divide natin both side by negative 1 pala. Yan. Plus 1 over 8, negative 1. So, pag dinivide natin 1 over 6 by 1 over 8, inad natin by 1 over 8, then sinubtract na, natin, na-raise natin by negative 1, the answer is also the same, 3.43 ohms. So, yan. So, ang computation for the parallel circuit. I hope na may natutunan po kayo ngayong araw na ito. So, maraming salamat po.